from Al Gore, and because of him, and this concept was generated. And actually, in his speech in 1999, and he gave a very broad and scientific understanding of this concept. And in his speech and his sketch, a visual representation of Earth in which a child would be able to see trees, to see buildings, to see cars over the Earth's surface. And this can be considered as the birth of this concept. And the next milestone, then we think it is because after this concept was given out by Al Gore, and the first international symposium on digital Earth was convened in Beijing, and the AI Digital Earth declarations was published. And in this declaration, and it gives very clear definition of the research scale for digital Earth from two aspects. One is on global issues, and another is on Earth systems. And it also underlined the 5 key technologies, for instance, information technology, global systematic observation and modeling, communications network, and database, and interoperability of geospatial data. And we think this is the first time that this concept was well accepted by the international scientists and by the international community. And the third milestone we think is after 10 years, and from 1999 to 2009, and another declaration on digital Earth was published. And in this declaration, it concludes 5 advanced technologies, because we think that the concept of the digital Earth involved with the advances of technologies. So this time, the 8 advanced technologies, and including Earth observation, geoinformation systems, global position systems, communications network, sensor webs, and electromagnetic identifiers, virtual reality, and grid computation. And this is the 3rd milestone. And the 4th one in 2011, and actually the ISDE organized one working group meeting in Beijing, and we invite 15 international scientists to come to here, and we have very deep discussions on the new vision towards 2020, because we think that most of the vision Al Gore given us is achieved by the development of the technology. So towards the future, we should give new vision. So from this working groups, and we published 2 papers, and these 2 papers both discuss the new vision, and we think that it's another milestone. And now we think that we comes to a new era. It's an era of big data, and we think that digital Earth is a very good big data enabled practice, and especially in the Earth observation and geosciences. So the big data brings new challenges and opportunities to digital Earth. So up to now, and the 9 international symposium on digital Earth and the 6 digital Earth summits was organized all over the world. And you can see from this slide, and we have many different themes for this conference. It also gave us another understanding that how this concept was developed. And here's one slide is something about the Institute, the RADI, the Institute of Remote Sensing and Digital Earth. Actually, the RADI, and they had 3 satellite ground receiving stations, and also 2 aircrafts for the airborne remote sensing. And we have 6 research departments, and we have more than 1,000 employees and students. And we also have Chinese Academy of Sciences key lab of digital Earth research, and you can see many different applications of digital Earth from different disciplines and laboratories. And here's one slide about our society. Actually, the ISDE was founded in May 2006. And the mission of the society is to provide a framework for understanding evolving society and newly emerging technologies, and to revise digital Earth vision in light of new developments. So besides society, the society's official publication is the journal, International Journal of Digital Earth. So we cooperate with Thailand and Francis, and now it's a CI index journal. And here it's just now I mentioned that the Digital Earth Vision, I think is really a good working groups, and we published 2 papers. One paper is Digital Earth 2020, towards the vision for the next decade. We published in the IGD, our journal, and another paper, Next Generation Digital Earth, published in the PNAS. And regarding on this, the content of this these 2 papers, meaning that the new vision of the digital Earth. And for instance, in this paper, Next Generation Digital Earth, and we consider that in the future, digital Earth should be a multi-connected infrastructure and based on the open accesses and multiple technological platforms. And another papers, and we think that the internet, some technologies like internet boundaries and also improved visualization technologies can help to define a new vision of digital Earth, especially the development of social networks. And on the right of this this picture is a digital Earth index, and representing that the state of digital Earth development of different countries. Very interesting illustration. And here is some good examples, and we think they are the digital Earth implementations for commercial use. Of course, most of us are very familiar with Google Earth and also Skyline, and Microsoft Virtual Earth. Now we call it the Bing Map, and the great company Israel ArcGIS Explorer. And besides that, actually in China, and we also have some digital Earth implementations. Mostly of them are 2D, and also we have some 3D softwares, like the National Administration of Surveying, Mapping, and Geoinformation of China have developed the 10D tool, and some other softwares developed by Chinese companies. And here we think that there are 2 very good examples for the implementations for science, digital Earth platforms for science. One is the NASA GPL Earth, and another is a digital Earth scientific platform of our institute. And the NASA GPL Earth, and you can see from many cases, and it can monitor all the NASA satellites in real time, and it also can display very good global scale research result. For instance, the carbon and dioxide, and the sea level, and other very useful applications. And here this slide introduces the digital Earth scientific platform of our institute. And actually, it has a 3D visualized environment, and also include that some geoinformation servers and databases, and it is a working platform for researchers and research demonstration, and also can provide information of the Earth. And many other applications of this DESP platform, for instance, the digital city, the digital heritage, and digital environment, for instance. So from all these implementations and cases, and we can see that these are 4 important components of a digital Earth paradigm. which includes the data, the model, and the platform, and applications. And now we think now this part of the data can give us more innovations and more understanding and how digital Earth can be in the future. And the next chapter of this presentation, I want to introduce something about the society. Actually, I'm working for this society as a communications officer, and for almost 6 years. And society is initiated by the Chinese Academy of Sciences, and the president of the society is Professor Guo Huadong. He is the academician of the Chinese Academy of Sciences. And the former president is Professor John Richards from Australian National University, a well-known Australian remote sensing background. And this is some pictures of the one our society was started in 2006. And the objective of our society is to promote international cooperations of digital Earth vision. So we have every year we have a symposium, and every odd year we have a summit. So meaning that every year we have a conference discussing digital Earth, and we're also doing a global digital Earth strategy consultant and the membership service, the journal, and the website newsletter. Is the secretary's job. Now, actually, the first symposium was organized in 1999, and the Beijing Declarations was published there, and more than 500 attendees from 27 countries, and to be in the conference. The second one, it was in Canada, with the theme of beyond information infrastructure, and more than 200 attendees in that conference. The third one in Czech Republic, in Brno, and the fourth one in Japan, in Tokyo, and the fifth one in San Francisco, US, with the theme as bring digital Earth down to earth. Very interesting conference. And the sixth one, and after 10 years, and this digital Earth symposium comes back to Beijing again, and so we have another Beijing Declarations, and we also have the conference proceedings, and you can see this from the pictures of the opening ceremony. The seventh symposium was organized in Perth, Australia. And in the middle, you can see very interesting activities during this conference, and a drone will fly over all the participants and make a shape of ISDE EoE, a very interesting activity in that conference. The eighth one in Kuching, Malaysia, Sarawak, and the ninth one in Halifax, Canada. So besides the symposium and the summit starting from 2006, the first summit it was organized in New Zealand, and the second summit in Germany, Boston, and the 2010 summit in Bulgaria, and the next summit in Wellington, another city of New Zealand, Wellington, and the 2014 summit in Nagoya, Japan, and this was in this year, and the 2016 Digital Earth Summit was organized in Beijing here, and with the theme of Digital Earth in the era of big data. And we think it make another new milestones for Digital Earth research, and especially towards the big Earth observation data era. And here is the introduction of the International Journal of Digital Earth. Actually, the journal was launched in March 2008, and now get indexed by the ICI and also indexed by other 12 databases. And we cooperate with Talon Francis. And this is the editorial board of the journal, and the chief Professor Guo Huadong, and executive editor, another professor in our institute, Professor Wang Changlin, and the letter editor, Anthony Lewis, and the book review editor job in January. And here is all the editorial board members. And the journal, the impact factor of the journal last year was 3.291, and it ranks the 4th out of 28 journals in remote sensing category, and the 7th out of 46 physical geography journals, ISDE journals, and both in the Q1 rule. And here is the distribution of the number of manuscripts by countries of journal, and here some remarks from our international community. And we also do some promotions work by the Secretariat Office. And next part is something about the ISDE's outreach. And actually, we have cooperated with the group on Earth observations, just like Dr. Derek Glidden introduced. Eye on the Earth both have this connection with GEO, and the ISDE is a associate member of GEO now, and we also cooperate with the Joint Research Center of European Commission, the CODATA, which is let's say the community of the ISDE, and especially on the research of scientific data. The International Eurasia Academy of Sciences, and also the Global Spatial Data Infrastructure Association. So it's our good partner. And here it's the slide that actually joined GEO and in 2009 in Washington, and to be accepted as a new associate member. And after that, the ISDE attended the many GEO activities and meetings and gave statements, and especially in the GEO's community to introduce the digital Earth and the digital Earth concept. And this is the GEO post 2015 working groups meetings, and ISDE with CODATA, and actually the CODATA's 45th anniversary was organized in Beijing here, and ISDE is one of the co-hoster of that meeting. And during that meeting, ISDE and CODATA signed MOU and to make more stronger cooperations between each other. And this is another MOU signing and within ISDE and GSDI, just 2015. And the ISDE and the IEAS, the International Eurasia Academy of Sciences, and in 2012 we held a digital Earth session and during the IEAS meeting, and we invite many digital Earth scientists to give speeches in that meeting. And the 35th International Symposium on Remote Sensing of the Environment, and ISDE is one of the co-organizers also. And we also organize a digital special session there. And some other international media partners, for instance, the Geospatial World Weekly Geospatial Media, and the 3 News Media, which is the biggest media partner in China, the biggest one on remote sensing, on Earth observation, and geoinformation science. And also GeoConnection is one of our media partners. So, and the last part of my presentation is some of my idea and how we could work together. So, and as I introduced that from 2009, 2008, and to now, and Digital Earth have many milestones, and now we think that the word of Digital Earth was given, and the Digital Earth concept is widely recognized for more than 15 years, and 80% of this vision have been achieved. So to the future, we need to have a new Digital Earth strategy. and especially on these domains, for instance, global change, digital city, food and water security, and natural disasters, and energy resources. And I think with other partners, for instance, the Eye on Earth community, the scientists in this community, also this organization, and we think we can do the research cooperations to solve global and regional sustainable problems. For instance, recently ISDE initiative a new scientific project. It's called Digital Belt and Road DBAR project, and also to solve problems like global change, urbanization, and natural disasters. And by building some kind of digital Earth data and information platform. So I'm going to introduce a little bit more about this DBAR project. And actually, the Belt and Road strategy is a national strategy of China.
John?
And yes?
John, this is Derek. Sorry to interrupt you. Could I ask you, could you speak a little bit louder, please? A couple of people are saying that they don't hear you so well. If you could get a little closer to the microphone. Thank you.
Okay. Sorry. As we know that the Belt and Road Initiative is a national initiative of China, and the Belt and Road regions and covers many countries and a large population. So we are going to set a new project and using Earth observation technologies to benefit this Belt and Road along countries. So this DBAR initiative is an international science and program for promoting cooperations with countries along the Belt and Road, and also to advocate and demonstrate the application of big Earth data in support of sustainable development of people and economic at local, national, and regional levels. And the main component of this DBAR project is a big Earth observation data platform, and the data are from, for instance, the ocean satellite, the communication satellite, remote sensing satellite, navigation satellite, and ground-based observations. And all these data and information were put together and in this platform and for the 6 applications. In terms of the coastal rules and the disaster, the world heritage, the agriculture and food security, and the environmental changes, urban development, and eventually for the science and policy makings. So here's some most introduction of the DBAR project, and I would like to invite the people in on the Earth community to join this project if you have the interest. And we think it is also a very ambitious project, and as ISDE is undertaking, and now we get many support from either Chinese government or from our international partners. And another thing, and I think we can do something together, is to publicity for organizing international conference. So, because at this moment we have the Digital Earth conference not yet covered the Middle Asia part, and we are also looking for very good partners and we can do together to organize either ISDE symposium or the summit or the workshops. And we also want to invite that scientists in unknown Earth community can have their understanding of digital Earth and publishing your research outputs in our journal, and which can improve individual research visibility and by publishing these papers. And join the society as members, and we have many membership benefits and for more involvements. And digital Earth education, and for instance, we have one professor from Austria, and he now is doing a new initiative for our society is called the Digital Earth Education, and it have many technically lectures on how to give digital earth education and how to make this education more in-depth understanding of the digital earth concepts. And so digital earth it is starting from visualize this planet, and now it comes to a global development. And our society is very eager to work with other partners, and we are for solving this global sustainable and global scale problems. So here is all my presentation for today, and so you can check our society's official website for more information, and also to writing emails to me. So I think that's all for my presentation for today, and thank you for your attention.
Thank you for giving us this presentation today. Obviously, the group has a huge portfolio. It really crosses so many issues. I just wonder if I could put a question to you whilst the people on the call get their thoughts together. A lot of what I saw was remote sensed imagery, but you've mentioned other non-image information and data types, and particularly I think I was intrigued when you referenced the sensor web. I ask what the activity areas in the field of sensors, the sensor web, and also models, if you're looking at predictive models and analytical models.
Okay. So, and it also comes back to that the Digital Earth Vision 2020, and some experts and considers in the future. So every information and every part of the objects on this planet are connected. So they think that from, for instance, the Internet of Things, and we can connect all the informations. So, and it's kind of it kind of the sensor maps, and all the individual people can be the sensors, and they are not only the people who getting this to receive the information. They are also the people who gave the information. So, and how to make these people and our objectives to connect with each other is kind of a very interesting topic of Digital Earth.
Okay, thank you. We have a question from Kostas Teregas. Kostas, I will unmute you if you would like to put a question. I think I saw your hand raised.
Thank you, Derek. Can you hear me?
Yes, I hear you.
Yes.
Thank you very much for this excellent presentation. I wonder if I could ask you a question to relate what you do with what the Ion Earth community has tried to do. We had a summit for Ion Earth just a few months ago in Abu Dhabi, and we agreed to separate our focus on three different areas. The demand side of geographic data, the supply side of geographic data, and then the enabling conditions that enable data from the supply side to jump over to the demand side and fulfill the demand. Using that three-tier system, how would you describe your own organization? Would you describe it as dominantly a supply-side organization? Are you interested in the demand for data? Or are you also looking at how to enable, create enabling conditions so that the supply can actually meet the demand? Thank you very much.
Yes, Castex, and thank you for your questions. And actually, because at this moment we have 16 people in our council members, and some people we have not yet achieved one goal, one common understanding of Digital Earth. And from our perspective point of view, because most of the people, Chinese scientists in this community, are more focusing on the Earth observation data, because we have the satellite, ground satellite receiving stations, and so we think that a kind of big data or Earth observation data platform. It's more oriented to achieve the goal of the digital observation. But there are some other opinions. For instance, we have Professor Nalni and from Joint Research Center European Commission, and they are more focusing on the especially the just Derek said the sensor maps and especially the use of the people and who can get information from their sensors. So so we have not yet achieved one common goal, but I think that the Earth observation is a really important component, especially in how to manage this data, and from the data we get geographic and georeference information. It's our one of our main activity.
Thank you for that.
Thank you. Derek, can I ask a follow-up question?
Yes, please go ahead.
So, you know, since you appear to be active in these areas as well as on Earth, I'm just wondering how we might push a little bit the collaboration more than simply join each other's community. Are there some projects that perhaps we might undertake together? How would we start a dialogue so that we don't simply spend time meeting each other, but actually creating some kind of joint efforts? Are there some ways that the Iron Earth community, which numbers in the hundreds of scientists and government officials and engineers and non-governmental organizations, begin to work with some of the information that's available in Digital Earth? I know it's a long trek that we have to travel, because there are many organizations, many conferences to attend, many events to underwrite, but are there some priority projects? Are there some calls for projects that Digital Earth issues that we might look on? Because I, like many of my colleagues, I'm sure, are very much excited by what we see and would like to engage in some kind of practical project. Thank you.
Yes, and thank you for this question. And actually, and as I mentioned in my PowerPoint, and we are recently starting this Digital Belt and Road initiative. It's ISDE's main one. I think it's currently, and also to maybe after 10 years, it will be ISDE's main international project. And I think you know, so if the any scientists and then the people in Iron Earth community have an interest into doing some joint research, and we can work together, or we can start from this project. Yes.
Thank you, Jon. We have another question from Ahmed Davi. Just give me 1 second while I find you on the list and unmute you. Here we go. Ahmed, would you like to put your question? Ahmed?
Yeah, thank you. Thanks, Derek. Jon, thank you very much. I was through the website about the Digital Earth, and I have a question about the self-driving cars that, you know, under Google and Tesla and these companies that are trying to do that. Is this technology, Digital Earth, going to help that also, technology for self-driving cars?
Yes, I think it's a new trend, and especially some not only Google, but also, you know, for instance, the Tesla is experiencing some new technologies on this car driving, and we have not yet covered this area, but we are more oriented to the data and the information infrastructure, especially for solving global scale or local scale problem for sustainable use, for instance, global change. So, but that's really a good technology advances, and I think we Digital Earth, because we are more oriented to the scientific research, Google is really a good pioneer and developer Google Earth and many other new initiatives, and especially for the commercial use. So, but ISDE is more scientific oriented.
Thank you. Thanks, Jian.
Yes.
Thank you, Ahmed, for an interesting question. We have another question from Anuradha. I will open your microphone now, Anuradha. If others have questions, please, you can. There's an icon, a little tool on the control panel where you can raise a hand, or you can type in the chat box as you wish. Anuradha, if you'd like to put your question, please.
So here from India. Okay, first of all, thanks for this very interesting presentation. I have a very simple question. I just would like to know from Digital Earth, the whole platform, is it solely meant for very technical persons, experts and scientists in the various areas, or do you have any plan or vision to reach out to the local community people, and how do you plan to do that? Because you shared in your presentation about education program, the Digital Earth education program, wherein you conduct lectures and trainings. So my question is, because I feel youth can play a very important role in creating a sustainable world. So what plans or strategies are there to enable the data that you have and to share this data with the youth, with the children, the students and the community who are not so technically sound or who don't have the scientific knowledge? So how can Digital Earth help in engaging the community people to make use of the digital data and to help in more building a sustainable world?
Yes, and yes, actually, the education project now, the ISDE having is called the Next Generation Digital Earth Citizens. And so it is not only that digital earth education, and also about to teach how the next generation to use the digital, for instance, a digital map, because the new generations are born as the new digital earth citizens, and we want to teach that teachers today and how to use the new technologies for their students. Because most of the teachers today are still not yet cover the digital earth technologies. So this is one project that one of our committee members is undertaking, and I think so. So if you like, I would like to introduce to connect you and with them. And as digital earth education can make everyone feel at home in a digital earth environment. So and all not only for the scientists but for all the stakeholders for digital earth. And they have the website, and they have many good lectures for teachers and for students, and they have a broad networks, and people within that network can communicate, and we think that's also another initiative of Digital Earth, and can especially benefit for the not only the scientific people but also for the ordinary people.
Thank you very much, and we look forward to some practical projects wherein the data can be made useful for creating a more sustainable world. Thank you very much.
Okay, thank you.
And thank you for the question. The role of the younger generation is obviously critically important, and access to tools and information in our highly connected world is clearly a basis for tremendous transformation. So a very important point. Thank you for that. Are there any other questions? Jordan, I see your hand is raised. Jordan Hastings. Good morning, Jordan. Thank you for joining us. I know it's very early for you.
Oh, good morning. I'm Jordan Hastings, University of California, Santa Barbara. And thank you for an interesting presentation. I've known about ISDE for quite some time, but this is the most extensive presentation I've seen. My question concerns semantics. You have many data sources over a long term. What approach does ISDE take to making them interoperable, because they do come from different points of view, and the users themselves will have different points of view. So the question is simply, what is ISDE's approach to semantics?
Yes, Jordan, thank you for your questions. And actually, I would like very much to hear your voice, especially from the Santa Barbara, because the Michael Goodchild, and he was our former vice president, also from the university from that region. And regarding on your questions, and actually, so this reminds me to think about the paper, and we published that's in the PNAS, and Professor Michael Goodchild, and consider then the next generation and digital Earth can also make full use of the voice, because we think that the first generation of digital Earth, for instance, the Google Earth are still. The Google Earth is powerful, but there's still lack of some functionalities. For instance, you're using the voice to convey more information, to telling people stories, to tell the new stories, and to make maybe some kind of thematic researches. So so we have, so within our community we have this kind of people that are still making that part of research, and we think that that's a very important part of the digital Earth component, especially in the future. Thanks.
Thank you.
Yes. Great, thank you. Okay. Well, I think at that point then I will bring the presentation to an end, and again extend our very great thanks and gratitude to Yong for the presentation. It's wonderful to hear from. I realize that ISDE is a global initiative, but it's great to hear speakers from China. There is so much work going on there, and it's wonderful that our group here, we have 22 people on the call, very many countries. We have people from California right the way through. We have had speakers from India, from Iran. I know there are people from Africa here. So it's a wonderful opportunity to get people to share knowledge, and I thank everyone for being here.